Good afternoon, everybody. Now I will speak about flax reinforcement for composite materials. So first, raw flax fibers have to be transformed to be used in textile process to produce textile reinforcement in composite applications. So, yep. Now I will speak about. Sorry, what happened? So after growing in field, flax must undergo some steps which are essential for yarn quality and finally composite behavior. So as my colleagues have already shown to you in the previous presentation, environmental conditions during growing have influences on fiber quality. So for example, rating, timing and climate condition influence fiber separation during scotching. After and finally, yarn transformation or spinning step give the final property of yarns. So after testing on scotch fibers, damarage species has been chosen, and we have sent 100 kilogram to a subcontractor to be spun in a wet spinning, which is suitable for long fibers, flax fibers. And we receive at the end 50 kilogram of yarn. Okay, so hackling is a fundamental steps since it splits and straightens the flax fibers, but also removes impurities and short fibers. So it produces flax sleeves, which are like a small ribbon, but without fiber cohesion. And these ribbons are then spun by using a wet spun process. So these steps are not made by partners because no partners were equipped with this kind of facilities, and it was subcontracting. So spinning brings resistance and the final thinness of the yarns. Yeah, I have a short video about flax ribbon spinning and finally winding step. I'm sorry it's in French, but if you have some question about this, you can ask in the chat.
La filature consiste à transformer les fibres de lin pour en faire des fils de poids et d'épaisseurs différentes. Les longues fibres fines sont filées à l'eau pour former un fil fin, les fibres plus courtes sont filées au sec pour obtenir un fil plus gros et rustique. Les bobines de fil sont ensuite livrées au tissage qui contrôle la qualité des fils avant de les utiliser comme fils de chaîne ou de trame. La première étape au tissage est l'ourdissage. Les bobines de fil sont placées sur un cantre et les fils sont enroulés les uns à côté des autres sur l'ourdissoir automatique afin de former une chaîne de tissage. Puis, les fils sont rentrés dans les lisses, les lamelles et le peigne, accessoires indispensables pour tisser.
So once the threads are made, we can pass to the weaving step. So for machine preparation, warp yarn can be installed on a creel or on a beam, like you have seen to the video. Beaming enables to put all the warp yarn in the same with the same tension, so the woven fabric will be better quality compared to with a quill. So to make the weaving trials at Centexbel, we are equipped with a small width woven machine with a maximum of 50 centimeter width that you can have a look on the picture. As you can see behind, we have the possibility to use a beam station here and also a creel to make samples. As we are not equipped with beam warp facilities internally, we make all the first trial by using the creel and small bobbins. For larger quantity, the yarn is winding by a subcontractor. Maybe some word more about machine specification. It is a multi-rapier machine with a Dobby motion of 18 frames. At this time, we can use 1 or 2 weft yarn during the weft insertion. And we have also now the possibility to weave 3D woven spacer or peel fabric with a new option called peel delivery device. Sorry. During the project, different kind of structure have been tested, like Twill 2.2 and Basket 4, which are common architecture used for composite application. We have also tested 3D interlock woven with satin 4 pitch. All the samples were made used a commercial flax yarn. So the peel with fabrics yarn density, so the last one, is characterized with 8 ends per centimeter, 8 yarns per centimeter in a Z direction, and 20 picks per centimeter for a final surface weight of 390 grams per square meter. Here on the schematic view of the 3D fabric, you can see here all the weft fibers. You have here the warp unidirectional yarns, and you have in color lines the typical movement of the movement in the Z direction. Now I will show you a short video of the Centexbel machine in action. So how it works, the shading movement where a part of warp yarn are raising or lowering thanks to the frame movement. Equals the picking, which is the weft insertion equals the width where the weft yarn is pushed up against the fall of the cloth by the reed. Sorry. After that, to check the reinforcement capability of the peel woven structures, some composite plates have been prepared with untreated flax fabrics and sealan treatment fabrics, and they were tested mechanically to compare their mechanical characteristics. So to prepare these composite plates, we use the vacuum bagging system, and we use as a matrix a commercial bio-epoxy. So after that, the mechanical characterization were performed by 3-point binding and dynamic mechanical analysis facilities at Centexbel. So here on the table, we have a we have a summary of the test results performed on coupons. So we can find flex modulus, flex strength, elongation, storage modulus, and TG onset. And we compare with untreated and treated fabric on a warp and weft direction. These results come from the peel woven fabric. So as expected, with 20 picks per centimeters in the weft direction, the 90-degree direction obtains the higher mechanical properties compared to the warp direction. And sealant treatment seem also to improve the mechanical properties, as we can find an increase of the values in all the parameters measured. So thank you. If you have any question.